Getting a couple questions about homework problem 1.47. Aluminum, gold, and iron have densities of 2.7 grams per cubic centimeter, 19.2 grams per cubic centimeter, and 7.874 grams per cubic centimeter, respectively. Suppose you have 5 grams of each metal. Match each picture with the correct metal. And so maybe the first thing that was throwing you off were the units. They've said that we have the densities in grams per cubic centimeter. That's what cc means, right? So 1 cubic centimeter. And so you've probably watched a medical show where the patient's in distress and the nurse says something along the lines of, give me 5 cc's of something stat, right? They're saying cubic centimeters. It's a measurement of volume. So 1 cubic centimeter, another way of writing it would be 1 cm cubed, is equal, right, to 1 milliliter. That's all that it is, right? So 1 cc is 1 cubic centimeter, measurement of volume. So now that we have the densities and we know what cc is, that cc is a cubic centimeter, we want to match each cylinder with the metal. So the first thing I would do is take into account all of the densities. So I have the density of aluminum at 2.7 grams per cubic centimeter. The density of gold at 19.2 grams per cubic centimeter. And the density of iron at 7.874 grams per cubic centimeter. Right, so there's two things we can do. We can make an educated guess based on the densities of what the volume should be, right? Because the larger the density, the smaller volume you would need to represent 5 grams of that material. So we might guess that gold, right, might be the smallest cylinder because it has the highest density. Because it has the highest density, you will need a smaller volume of that material to represent 5 grams of that material. And we might guess that aluminum is the largest cylinder, and that would leave iron right in the middle. We can do that calculation to confirm that is the case. So I have aluminum, and let's say I have 5 grams of aluminum. That's what we're given, 5 grams of each of these metals. I want to turn that mass into a volume. So if I have 5 grams, I need to multiply that by something that will turn mass into volume, into cubic centimeters. Well, the conversion factor is right here. The conversion factor is density. Density will allow us to convert from mass to volume. So when I go and use that conversion factor, I want mass to cancel out, so I should put 2.7 grams down here for every 1 cubic centimeter. And then when I multiply that across, grams cancel out, and I'm left with approximately 1.9 cubic centimeters. That should be the volume of 5 grams of aluminum. Do the same calculation for gold. I have 5 grams of gold, and the density of gold for every 1 cubic centimeter of gold, I should have 19.2 grams of gold. Well, we have much less than 19.2 grams of gold. I actually only have 5 grams, so I should have less than 1 milliliter, 1 cubic centimeter of gold. I do that calculation. I have about a quarter, actually, about 2.6 cubic centimeters of gold. And last but not least, the iron. The 5 grams of iron, I have a density of 1 cubic centimeter for every 7.874 grams, and that turns into a volume of approximately 0.64 cubic centimeters of iron. I kind of glossed over significant figures, but we have 2 significant figures in all of these measurements here. This should be 5.0. 2 significant figures there. We do have 3 here and 4 here, but we're limited by this is our least significant number. 5.0 has 2 significant figures, so I'm going to report the final answer to 2 significant figures for all of these calculations. And then we can go over here and match those with the appropriate cylinder. So cylinder 1 has the smallest volume. The smallest volume comes from gold, right? So that matches what we guessed. We guessed that, right, B, which was gold, should be the smallest volume. Number 2 has the largest volume. Well, that's what we calculated for aluminum. So I would put A as aluminum. And then the last one, as we said, right in the middle, that should be iron. So again, just thinking about what we know and thinking about what is density, right? Density is mass over volume. So for something that has a very large density, right, what that means is we have a very large mass in a small amount of volume, right? We've got a large number here divided by a small number here. That'll give us something with a large density. So what that means is we would need to have a small volume of that material to have a large mass. So hopefully that helps with the calculations for 1.47. But like I said, you could do the calculations to confirm that. You could also kind of think about density and make some educated guesses as well.